Hello, everybody. This is lecture 5, and in this lecture, we are going to learn about the file input output. Now, the file input output operations are usually employed for storing information or to read information from a file. So, the LabVIEW has inbuilt functions and the VIs that handle the file input output functions. So you can access it by going to the functions palette and then selecting file input output. And from there you can see like three different rows. So the first row is nothing but the high level of file VIs and the intermediate file functions. And then in the last row, you have the advanced file functions. In this lecture, in this course, we are just going to focus on the high level and the intermediate file functions. So the basic operations in a with intermediate file functions involves like opening or creating a file and then reading data from it or writing data to it and then closing it. So there is a specific VI to open a file or to replace, or you can use it to replace a file or to create a file. One of the terminal is file path. You can specify the file path, or otherwise, if you don't give a file path, then the VI displays a dialog box from which you can choose a new file or an existing file. So then the output would be a reference number. Reference number is like a unique file identifier that is generated whenever you create a new file. And you also see that there is like for each of these VI, we have the error in and error out. So these are dedicated units to track any kind of errors. And they are like cluster data type, as you can see here. So yeah, similarly for read file, you have like reference number as the input, error in. The others are like optional terminals. And then at the output, you have the data and then error out, write file, and then you are supposed to close the file. So, and for the checking errors, as I said there is like error in and error out. So these are cluster data types, and it has like status, code, and source, which is useful for tracking the errors. And also at the end of like, after closing the file, you can use the simple error handler, VI, that it checks for any kind of errors in the file operation while you're doing this operation and displays a dialog box if an error occurs. Now I'm going to demonstrate how to read and write a file using intermediate file input output functions. So let's log into the LabVIEW. So I'm going to demonstrate the exercise 7.2. So the object is to write data to a file. So you will build a VI that will concatenate a message string, a number, and a unit string to a file. You will use the sub-VI created in exercise 7.1, build string.vi. In the next exercise, you will build a VI to read the file and display its contents. Okay, so in this file, we are just going to um, write data to a file, and then we are going to read the same file in the next exercise. So let's go to our block diagram. Okay, now just going to go here and use the file input output. So I'm going to open a file, then I'm going to use a close thing. Write text file. Then I want to go here. So I want to add the simple error handler. So this is the VI. Then next, what I'm gonna do is for the file path, so I want it to give me a prompt. So I will display the file path using an indicator. So I have to go to the string and path and select file path indicator. Okay. What's the error? Okay. So the error that I have here is I cannot show it as an indicator because it's an input to the file. So it has to be a control. So I have to choose create control. And then can remove the indicator from here. Okay, but I prefer, so you see like here, you can write down the path of your file here, but I personally don't prefer doing that. I want it to prompt and show me the dialog box, so I'm removing, but if you wish to do it, you can do it. So next terminal is operation. So just right click on this and control. So from here, you can choose what you want to do: open, replace, create. Let's expand this, open or create. So choose this option. Okay. Then yeah, we connect the reference number output to reference number in. Let's see what's this terminal. It says cancelled. Okay, it's an optional terminal. So you can ignore. Okay, this is connected to this. This is connected to this. Okay, you cannot connect this to this. You'll end up getting error. See? So because it's just an error handler, you just need to pass the error out to this VI. Okay, now we have to create some, what we have to create things that we want to write it in our file. So the first one has to be a string as shown in the example. So I'm going to choose a string control, another string control, and a numeric. Okay, so in the string, we have to write the measurement is, and then in the, and choose some value here. Just gonna write 12, and here it's going to be volts. Okay, so I have created the contents of my file here, and I need to wire them up. This is my string 1, string 2, and numeric. So I need to concatenate them. But before that, I need to convert the numeric into string. For that, I will use a function. Go to string, choose format into string. Yeah. We are connecting it to input 1, and now the output would be a string. Now to concatenate strings, we go to the string palette and choose the concatenate. So in the example here, they are using a build string.vi. So it's like a previous exercise. So you now I'm not creating that sub vi, but you can practice. Either do it that way, or I'm just going to do it directly because it's just a demo. So for you, you need to create the build string.vi and then do this, implement the same program. So this is our concatenated string, and we want to give this as an text to our file. Okay, so we are done. Now let's run this file. Now it prompts me because I like it this way. You can choose to, create a file path controller and enter the file path there. So I'm going to name this as file IO lab 5. Okay, so yeah, now I'll just go and check that file here in my C drive. Open with the notepad. So here is the output. So it's very simple. So we have learned how to write to a file. Now the next thing would be to read that file. So we are going to do the next exercise. It's exercise number 7.3. Okay. So I have to go into my lab view. Okay, now the same thing, we just go to file, input, output, create, open file or create file. Then we say close file. And then we have to add the read sub VI. Read text file. And then we need to add the error handler, which is in dialog and user interface. Okay. And then connect them. Okay, now I'm just going to add a control. So this I'm going to put like open, and I want it to prompt me. So I'm not going to add the file path. And then this is the data. So I'm just going to create a indicator, a string indicator. Yeah, so that's it. So let me go and check on the front panel. Yeah, it's in the open mode. And let's enlarge this. And I'm going to run this code. Now it's prompting me to read which file. So I want it to read the one we created just now. So here you see it's reading that output. Okay, so now we are done. We have learned how to read data from the file also. Now moving on to high-level file VIs. The high-level file VIs have inbuilt open and close functions. You don't need a separate VI to open and then close it. Suppose if you call write characters to file VI, then it automatically opens it and closes it. And also it has an inbuilt uh, um, spreadsheet string format. It changes the numeric array data from and to a spreadsheet string format. So you don't have to do it separately. So this is a VI that writes characters to a file. Then there's another one to read characters from a file. And then you have like write to spreadsheet file. So these all can be used just and this single VI is enough to open, close, and convert into a spreadsheet string format. Then read from spreadsheet VI and read lines from the file VI. So I'll be doing the so I'll be demonstrating one of the exercises which deals with reading and writing from spreadsheet. But then the table is on as a front panel control, which can be used to pass or display data in a tabular form. So the data type of the table is a 2D array of strings. So just make sure like you are not inputting numeric values. They have to be converted into a 2D array of strings. Now you have the optional row and column headers, which can be added using the property nodes. And the way you create a table control is by selecting table from list and table subpalette from the controls palette. And this is an example. So here you can see there's a random number generator. It's formatted into string, and then it is sent into a table. And if you want to create the column and row headers, then for that you have to use again a number to string converter, and then we are using the property node. This now this string is being passed to the header, and the column header we are going to create an array of string constants for that. You can make these row and column headers visible using a Boolean control. Now going to I'm going to demonstrate this example. So the objective of exercise 7.5 is to save a 2D array in a text file so that a spreadsheet can access the file and to display the numeric data in the table control. So from the front panel, we can see that we need to show a table here and also show a waveform graph. And then also save that data, this data into a file in a spreadsheet file. So let's start. Now first I'm going to going to go to the signal processing, then choose signal generation and create sign pattern. And I'm going to copy paste another one with a phase of 90 degrees. Create constant, and then I can enter 90 degrees here. Then the other one would be the uniform white noise. So again, need to go here, signal generation. Okay. And now need to create an array. So build array. So I have 3 inputs, so I've just got to expand this. Then this is going to be the appended array. Now we are going to create an indicator. Okay, we can create a waveform graph. And then we also have to create a table here. So as you can see from the thickness, we know that it's a 2D array. Now, so we have created a waveform graph. The way now the build array vi, the way it is going to arrange this, the inputs would be like, it would be like the sign pattern would be in the row 1, the noise will be in the row 2, and the cosine will be in the row 3. So, but we want to have the display something like this. So we want each of these waves like sine, noise, and cosine to have to be arranged in different columns instead of different rows. So for that we need to okay, let me show you how it looks like. Sorry, my the computer got stuck for a while. Okay, now let me show you that here. So here, so the output of the build array would be, array function would be like a sine array, would be arranged, all the values would be arranged in the row 1, then the noise array would be arranged in the row 2, and the cosine in the row 3. But and this would be the output of the our build array, but the way we want it to be in this format, therefore we have to perform a transpose function. So going here, I go to array and transpose to the array. Okay, connect this, this, and this is the transposed array. And I would like to store this value in a file. Therefore, I choose the file input output function and write delimited spreadsheet. Yeah. Then next, we would also want to display this in the table. So for that, first we need to convert this numeric array into a string. So we go to string, number to string conversion, number to fractional string. So we are converting a numeric array to a string, to an array of strings. So the number would be connected here. Would be connected here. Oops, what do I see? I get an error. You have connected the output of the number to a fact. Okay, change the, oh, we need to change it to a control. So let's delete this. Now this is format string, replace. Okay, just delete this. Even delete this. We can change this to indicator here. Okay. And then I can connect this here. Okay. Then you can create some free labels here if you want. So this is our table control now. We can add, you have some option of editable headers. So you can write here, just check that, and sign, noise, and this will be cosine. Yeah, you can make, like some changes by going to the properties, and you can even add to the rows, you can add the header. Okay, and this would be my waveform graph. Let's see what they have shown in the example. Okay, it's as it is waveform graph, and we need to expand this a little here to show the legend. We have 3 plots. So the first one is sine. Let's change this to sine. The second one is noise. And the third one is cosine. Okay, so we are done now. Let's run this code. Now it's prompting me to give a file name. So I will give this as lab5 spreadsheet. Okay. As you can see, we can see all the data here. Oops, it's not showing me the headers. So go to visible items and show column headers, check column headers. So we can, as you can see, the column headers are not shown. So you just go to visible items and check the column headers, and now add it. This is sine, this is noise, and this is cosine. Okay, yeah, now this is fine. Now we can run this and store it. Lab5 spreadsheet. I'm going to overwrite it now. Okay, now let's go and check our spreadsheet file. Open with. So you can open with Notepad. So as you can see here, we got the data. So what it does is, if it is an already existing file, it doesn't replace it, it appends the data to it. I'm sorry, I just said that it's going to replace the file, but it's going to just append the data. Okay, so yeah, so this concludes our lecture 5. Thanks for listening.